In this video, we'll discuss volume. Now, volume is the amount of space a solid occupies. And like area, we can use the moving and additivity principles to help us calculate the volume of a given solid. And that comes into play also when we think about Cavalieri's principle. This is another unique aspect of volume with solids. Here we know that if we have two solids that have the same cross section throughout the entire solid, and they have the same height, then they have to have the same volume, which is very useful when we think about oblique solids, kind of like this image here of the two cylinders. They have the same radius and they have the same overall height. That means they have to have the same volume, even though the ones kind of turn sideways. Think about it as if we took two stacks of nickels. Both stacks have 10 nickels in them, but just because we turn it sideways doesn't mean the volume of the number of the nickels would change on that right-hand side. Now, when we want to calculate the volume of a solid, we need to recognize some of the parts that make up the solid. We can have the area of the base, that's our capital B. The lateral area is our capital LA. P will represent the perimeter of the base. H will be our height of the solid. L will be the slant height, and then R is the radius when we have circles. So here are the 5 formulas we typically use with volume. And again, you'll be provided these 5 formulas. Just pay attention to the different letters and how we apply them in solving for the volume. So let's look at an example. Say that we have this cylinder that has a diameter of 16 inches and a height of 20 inches, and we want to keep the exact solution for the volume. So let's label the parts we have. Here we have the diameter. It's 16 inches. However, none of our formulas talked about diameter. Instead, they use the radius. We know the radius is half of the diameter, so we'd say the radius is 8 inches. Next, we look at the height. The height is given to us as 20 inches. Now we can take and look at the formula. What's our formula for the volume of a cylinder? It's the radius squared times the height times pi. So we can now substitute in our values. 8 squared times 20 times pi. And they want the exact solution, so that means we will keep pi in our solution. If they want to approximate, we would then use the 3.1415 or just use the pi key on our calculator. So if I do 64 square inches times 20 inches, that will give me 1,280 pi cubic inches. Again, we keep the pi to keep it as an exact solution. Now, what if we have the volume of a pyramid? Here we got the Great Pyramid of Giza, which we know has a square base that is 756 feet. And it's calculated that the slant height is about 591.5 feet. And we know what's the volume of the Great Pyramid. How much space does it take up? And so what we can do here is then use our formula for a pyramid. But let's start with the pieces we know. We need the area of the base. So the area of the base is capital B, which is the area of the square base. So area of the square is length times width, which happens to be the same value, 756 feet. So that will be 571,536 square feet. That's the base of our pyramid. The next thing we need is the actual height of the pyramid. Now you have to remember, where does height exist in a pyramid? It exists in the dead center of the pyramid. So what that means here is that it's in the dead center, so it's halfway from one side to the other of our square pyramid, and we're also provided the slant height. So let's label the parts we have. We have the slant height, which is 591.5 feet, and then we have halfway to the height, which is 378 feet. Now, what do we notice we have here? It's a right triangle, so we can use Pythagorean theorem to calculate the height. So we'd say 378 feet squared plus h squared should equal to 591 feet, and that quantity squared. When we simplify it, we continue to carry our decimals as far as possible, and then we take our square root. Now, when you take the square root, if you're using a calculator, try to pull as many decimals as you can. Use the answer button as you go forward to get as accurate a solution as possible. Here I've rounded to 5 decimal places, trying to again pull as many decimals along as possible to get that the height's approximately just under 455 feet. So I'm going to use as much of that though to help us calculate the volume, because we know the volume for a pyramid is 1/3 the area of the base times the height. Well, we calculated the area of the base and we just calculated the height. and we're going to multiply through and then approximate to the nearest foot. So we're going to round to the ones place, which gives us approximately 86,675,265 cubic feet that it covers with its space. Now we've looked at the volume of solids with that have formulas. We can also deal with solids that don't have formulas using our principles. For example, here we have a water tank that's used to help make sure cattle have water. And they're often about 6 feet long, about 3 feet tall, and about 2 feet wide. And we want to know, well, how much water will this actually hold for the day to the nearest gallon? And we'll use the conversion that a cubic foot is about 7.5 gallons. Now this shape is not a shape that we have a formula for. It's kind of ovular, it's an ovular type of solid, but what we can recognize is if we draw in some lines, we see some shapes that we can calculate the volume for. What we see is that we actually have a half cylinder on the left, a half cylinder on the right, and then a rectangular prism in the middle. And if I have two half cylinders, I can take the two, put them together, and now I have one whole cylinder and a rectangular prism, which is much easier for us to calculate. So let's start labeling the parts to each of these. So we know that the width of our tank is 2 feet, when the width would also represent the diameter of the cylinder. So we say the width is 2 feet, but remember, a cylinder, we don't care about the diameter, we care about the radius. So we say if the diameter is 2 feet, we know the radius would have to be 1 foot. The next thing both of these solids need is the height, and the height is given to us as 3 feet. Now we need one more side for our prism, which is this length from left to right here. And what we know is the whole thing is 6 feet, but we don't know this part right here. But think about how we cut up the water tank. We said this was a half of a cylinder. So if we think about from this line here to the edge, that's going from the center of our cylinder to the edge. That's called the radius. Well, we already said the radius was 1 foot. And we do the same thing over here and say that this radius would also have to be 1 foot. Now, if we think from one length to the other end, we would say that total length has to be 6 feet. So 1 plus what plus 1 gives us 6 feet. It would have to be 4 feet. So we do know that length would have to be 4 feet there. Now we can calculate our volumes. We'd say that we're going to add up the volume of the cylinder and the volume of the prism. The volume of a cylinder is the radius squared times the height times pi. The prism would be the length times the width times the height. And we simplify them individually, and that would be 3 pi cubic feet and 24 cubic feet. And you see I left that exact for now. But we need to change this over to gallons, so we do need to approximate by adding 3 pi and 24. And that's approximately just under 33.5 cubic feet. But again, we're converting, so we want to pull as many decimals from one line to the next. So use that answer button or write down as many of the decimals as you can as you go along. Now we need to convert. So I'm going to convert by using the cubic feet to the gallons and make a proportion, because I know that this ratio has to be equal to the ratio based on the information I have. So I know that my conversion is 1 cubic foot to 7.5 gallons. That can make up my left-hand side. And then I say, well, what do I have on my right-hand side? Well, I just calculated the cubic feet as 33, and then all my decimal just under 33.5 cubic feet. And I don't know how many gallons that represents. So I cross multiply here, and I'm going to get 1 cubic foot times x equals just over 250, about 250 and 7 tenths cubic feet times gallons, because I'm keeping all my units, so that when I divide both sides by 1 cubic foot, the cubic feet disappear, and I'm left just with gallons. So I can say that I have about 251 gallons of water in this water tank, because they wanted us to round to the nearest gallon.